Alright, so the integral of sine ax squared by cosine ax squared. How do we go about solving this? Well, unfortunately, there's no solution to this integral in terms of elementary functions, because the x squared term that the functions are dependent on won't provide a closed form solution. But we still can get an answer in terms of an infinite sum using the Taylor series. But first of all, let's simplify the integrand in here. And here's where trigonometric identities can be very helpful. The particular one that can help us here is the double angle formula, which states that 2 times the sine of u by the cosine of u is equal to sine of 2 times u. Alright, then of course it follows that the sine of u by the cosine of u is equal to 1/2 times the sine of 2u. So if we make the substitution u equals ax squared, then we can write the integrand as sine of ax squared by the cosine of ax squared equals 1/2 times the sine of 2 by ax squared. So thus the integral of the left-hand side is equal to the integral of the right-hand side. And of course the constant coefficient can come out the front of the integral. Okay, now the integral of 2ax squared is what's known as the Fresnel integral. And we usually express that as big S of x is equal to the integral from t equals 0 to t equals x of sine of 2at squared dt. And I've already made a video on how to find the expression of this integral in terms of an infinite sum, and I'll provide a link to that. So I'd encourage you to pause the video now and review that. But this integral evaluates to the sum from n equals 0 to infinity of -1 to the power of n by 2a to the power of 2n plus 1 by x to the power of 4n plus 3 divided by 2n plus 1 factorial by 4n plus 3. So that's quite a mouthful. But if we finish off by substituting this now for the integral, we can express the integral of sine of ax squared by cosine of ax squared with respect to x equals the sum from n equals 0 to infinity of -1 to the power of n, 2 to the power of 2n, a to the power of 2n plus 1, x to the 4n plus 3, divided by 2n plus 1 factorial by 4n plus 3. Alright, so I hope this has been helpful, and if so, please like, subscribe and share. And because these videos take me a lot of effort to produce, I would really appreciate a small donation so that I'm able to continue to provide these resources for math students of the world into the future. Thanks very much for watching, and I'll see you on the next video.